I ended up going to my local electronic parts store for some batteries and a couple other things I needed, and I found some terminal posts that fit into a banana connector and or could access the terminal by putting a piece of wire or possibly your multimeter probes in there, which is what I plan to do. I found some that were a little safer than what I had before. This is what I had and didn't want to use. As you could see, that whole post is not insulated in there. So I wanted to abandon the idea of putting that in there, but I found these. These are insulated all the way through, so if they get loose, you won't have a problem of energizing the cover. So as you can see, I've already drilled a couple of holes with the spacing of a typical banana connector. This one, obviously, I would not use because it's unsafe. It would end up energizing this part as well too. I just use this as a guide for my spacing. So what I'm going to go ahead and do is put those on. I've already drilled the holes, and I cleaned up just a little bit of this on the back where the drill bit broke through. And the reason why I'm not making that super smooth on this side or that side is so the terminal post have more material, actually not more material, but a rougher material to bite to when I screw it down. So let's go ahead and put these in. And it just so happened that I got red and black, but in this case, because primarily I'll be using it for alternating current, there's not going to be any difference between one side or the other. However, you could actually use this to test any kind of circuit that you would need to run clockwise and counterclockwise, or a circuit that shares a neutral conductor that has two different parts of the circuit. But anyways, I'll be using it for AC motors. So let's go ahead and mount these, and hopefully we got the spacing right. Well, it looks okay. Let's see if the spacing's okay. Looks like the spacing's okay, so I'll probably just buy some generic test leads and connect them with banana connectors on each end, and use that exclusively for my voltage testing. Or what I had originally planned on doing was just using my test leads. The thing I don't like about the test leads, looks like I'll have to adjust these. The thing I didn't like about the test leads is that they stuck out. So that part would be energized when the circuit's energized. So for that scenario, I thought it might be kind of unsafe to do. With these particular probes, they wouldn't be all that unsafe because you can electrically insulate the conductive part of the probe, and you just don't stick it all the way through. You just stick it a little bit and then screw it down. So it looks something like that, and that would be pretty safe as opposed to having a stick out of that much. All of that would be energized. So with these fluke probes, I can insulate that. I think that would be safe to operate. I still probably am just going to do a banana connector, but in a pinch, that would be safe. But do this part at your own risk. Well, do the whole thing at your own risk. Do everything at your own risk. But anyways, so that's what my thoughts are on getting the voltage reading at the same time as the current reading. So let's put it together and see how it works. I'm gonna have to modify the circuit a little bit. I've got to pull a neutral lead to one of these terminal posts and then cut those off so they're not sticking out as much. I'm gonna pull the hot lead off of these terminals and the neutral lead probably off of this wire. And I'm pulling the hot lead off of either one of these as opposed to what's electrically energized all the time. That way, this only is energized when I've got it on or off. If I pulled it off either the line, incoming line, prior to it being broke off the switch, I would have these terminal posts energized all the time. And I don't want to do that. So probably going to have to cut this insulation back. I'm going to use this incoming neutral line for my banana terminal post. So in order to do that, I've got to cut this heat shrink. I'm going to use this scrap piece of wire to make another splice on the incoming neutral. First, I'll tin this side, make it a little bit easier to solder. I stuck it in this connector right here to make this a little bit easier to grab hold of. I'll desolder this connection again. I'm going to see how putting two different sizes of heat shrink on here works out. It may not work at all. I'm going to go ahead and put two small pieces on this side. And then I'll get a bigger piece. Maybe something like that'll work. So I'll use the thicker piece on top of this whole splice right here. Put that on there first. And then I might have to put that up there to a certain part. This is going to be a little tricky. Let's see if we can get it to work. So I'll just run this one up as far as I can. Actually, looks like that's going to work by itself. I'll put the thicker heat shrink on there for the fun of it. I'll use this black wire as my incoming hot line. And I'm just going to go, it's just going to go from, oh, actually I already determined that I was going to do two of these. Hopefully I've got enough wire here to do it. I bought a couple of these smaller terminal rings to fit on here. And it looks like I'm already missing a screw from there. Oh, there it is. Hopefully that's going to work. I think I'm going to put some heat shrink on this too. Well, that's not going to work as I thought. I was hoping to slip this up. I guess that's probably as good as I can get. I've already thought about cutting them off so it doesn't stick out as far, and I guess I'm going to have to do that. Let's just see what this does. Double check all my connections here real quick, make sure that these are on solid. This is what I was hoping I could do for the other side, which was get it further on there. Once I cut that off, get it further on there and then heat shrink it so it's less likely to short out on anything. Primarily short out on me. I'm going to cut these two terminal posts off, and that'll give us the ability to push these down, push the heat shrink down a little bit and make it more secure. Hopefully you can see that, but I cut the extra part of the posts off just with a Dremel, and it looks like I cut into the screw right there. I think that'll be okay. We'll see how it holds up. But what my intention was with the shrink wrap is to do this. To have it where it would shrink over the terminal a little bit. But since I tried to do the two posts over here, I definitely don't think it's going to work. But there may be another way around it. I'd probably just put some tape on it if I put any clear conformal coating or anything like that before I heat shrink these. It could quite possibly be that that melts. So I may do it afterwards, but let's just go ahead and use the heat gun and cover it up as much as we can. Maybe if I had a bigger piece of heat shrink, this one would work out. That didn't go as planned. I didn't push this piece down as far as I wanted to get it on there. So I don't want to back these off because I'm afraid I won't be able to get it back on. So that'll just work for now. It's not really doing anything but just adding strength to this connection. And let's see how that works. Let's go ahead and hook everything back up. Let's see, incoming power, I'm going to go ahead and put that on this common pole. I'll just put it on that side, it's fine. These two are electrically the same. And then I'll just throw these over here. I'm going to go black on the bottom, and I'm going to go white on the top. And I may have mentioned this before, that I like doing everything top to bottom, left to right, alphabetical order. And the reason why I'm not doing that with this hold on. Let's see. Considering this will be the top, and I have white out of alphabetical order, is because when I flip the switch down, it's actually going to be white, and when I flip it up, it's actually going to be making the connection electrically the same with this black lead over here. So just a side note, there's no code or anything like that I'm following. And I guess that's one last shot before we put it together. There's my little splice that I made off of it, and everything else. So let's see if we can get this to fit in here. Just gonna double check my spacing, make sure nothing's moved around, and look at the holes under here, make sure they're all right. Yeah, so the holes are still lined up where I want them to be. All right, let's do some tests on this. So now that we've got everything electrically connected, I want to test the circuit before I test it with a load. So I've got an example of how this would be set up, with the exception of you would most likely only be using one voltage reading and possibly two current readings. The only reason why I have this meter set up is to measure the outgoing current, and that's just to see if electrically it's working, if it sends current actually to the legs of this cable that we expect it to, and make sure that there's nothing else that's faulty. So again, this would not be used. The circuit is de-energized as of right now. That's why we're not getting any voltage or current readings. We will not be getting a reading off of this because we're not going to be actually testing a load. There may be a few hundred milliamps of current that show up, but it's not because of there's a load going through there. We're only going to be putting probably a 1 meg or a 10 meg ohm load on it, so there's not going to be any current draw. There shouldn't be any current draw, so we'll see if there is. Let's energize the circuit and see what we come up with. I have the incoming voltage plugged in, and this outgoing line right here is what's going to these three wires. So as of right now, everything shows that it's de-energized, and that's exactly what we would expect. So now if I switch the switch on or off, I should get some voltage readings. And the fact that I'm getting some kind of voltage reading here is probably just a capacitance voltage from the internal wiring. Because it's so loose and the wiring is so close, there's probably some kind of capacitance voltage coming across there, and that's why we're getting these small readings of voltage. Or it could just be because they're so close by the switch. I'm going to turn the switch on in both positions and see what we get. Now these particular wires correspond to the color wiring that is coming out of our box, and that would go into the motor. So our white and black are going to be hot, and our green is going to be neutral. If I flip the switch up, I should see voltage on this meter and voltage on this meter. If I flip the switch down, I should see no voltage on this meter and voltage on this meter. This meter is measuring the incoming current, and this meter is measuring the outgoing, what would go out to the motor, and only one leg is energized at a time. So let's see if it works. That's not what I expected to see. That wasn't what I expected to see. Let me see what kind of voltage I get just between the two hot legs. I'm getting a voltage reading every time from the outgoing, which I should only be getting at half of the time. I should see no voltage there, and I should see voltage there. So, and I should see voltage here every time, and I'm not getting any voltage. All right, let me try a different setup and see what I come up with. I think part of the reason why I was getting some weird readings was because of some capacitance voltage or ghost voltage. So I brought in a meter that has a low impedance mode. I think it has a 1,000 ohm resistor in low impedance. So it should load the circuit enough to get rid of any of that. So again, the test setup that I have is I have this meter is going to be measuring outgoing voltage from the box to the load. This meter is going to be measuring voltage, incoming voltage. Okay, so no matter if I switch up or down, I should see voltage on this meter. If I switch the switch up, I should see only the white leg get hot, and if I switch it down, I should see only the black leg get hot. So let's see what we get in the up position. So that proved wrong. So I've got something that's not wired correctly in here. I'm going to de-energize the circuit. Let any weird voltages drain off and open this thing back up. So I made a rookie mistake. I forgot to energize one side of the common on the second pole. So I think I'm going to do another splice off the hot leg over to here, and that shouldn't take that long. I'm just going to put one tube of heat shrink as opposed to do the smaller ones like I did here. I think that'll be sufficient. This lead I'll cut it in half and turn it into 2 leads, and that'll be what I use to split off of here. There's probably some little trick or something to just break away that insulation or something, but if there is, I don't know. This is going to be borderline disaster, but we'll see if we can bridge this gap over here without burning too much stuff. I just realized I forgot to put the heat shrink on there, and I think that'll be okay because I don't have these ends done yet. Not great, but it'll do. If I had to redo that again, I would probably put a second set of heat shrink on there because my solder joints are so bad. They've got all those bubbles and all that crud sharp points in there that could easily over time bust out, like for instance right there. But a little bit of electrical tape and that'll be good to go. So again, my mistake was that I did not energize one side of the switch. So with this, I'm energizing the switch to do what it's supposed to do, which is send current to whatever my load is, and then I am energizing the second part of the switch, and I am just using that for a voltage reading. So I'm going to be flipping it to closed position here, closed position there, and that'll just give me, that'll energize these terminals, but only when the switch is on. So let's put it back together and see what we get. The only thing that I probably would have done again before I buttoned everything back up was take one of my leads on my meter and put my meter on continuity and test different points to confirm that there's no continuity between the housing and any part of the circuit, and confirm that there is continuity between ground and the box. But that's hindsight. I don't think it's a big deal for now. I'm 100% sure that I'm connected to ground off of this post directly to the wall. So let's go ahead and energize the circuit and see what we get. So the test that we did before was faulty because the wiring was not correct. So now that we've got what we believe the wiring to be correct, we're going to do a test. We're just going to test voltage without a load. Again, we've got these leads hooked up to this particular meter, and we should see voltage in the down position and the up position. And because we have the white lead and the green lead connected, which is neutral and hot, we should see voltage in the down position, but no voltage in the up position. So let's go ahead and switch it down. So we're supposed to see voltage all the time here and voltage only in the down position here. So now let's switch it up. And we've got voltage here, and then we've got some leakage here. So let's put a little bit more of a load, switch these meters out, and let's see if we still see this leakage right here. All right, I've switched the leads on the meters. So now we're going to be seeing voltage here in the up position and the down position, and we're going to see voltage here only in one position. In this case, we're going to only see it in the down position. I put it in low impedance mode, so if my suspicions are correct and that 36 volts that we saw over here before, it should not show it on this one because we have a little bit more of a load on the circuit. So in down position, we'll see voltage on both. That's what we expected to see. And now we should see voltage on this, which is now connected to these leads, and we should see a couple of volts here, or what we're ideally looking for is no volts in the up position. So let's see what we got. All right, so that's exactly what we expected to see. So now let's go over to our black lead, and now we're going to see the reverse. We're going to see voltage in the up position on this meter and voltage in the up position on this meter, and then in the down position, voltage and no voltage. So down position first, exactly what we expected to see, and then up position. And that's exactly what we expected to see. So for the fun of it, let's just take a look and make sure that there's nothing crazy going on between these two terminals. So we expected to see voltage there, no voltage here, and now we should see no voltage here and voltage here. All right, so that's exactly what we expected to see. So I didn't get shocked, so electrically I think we're okay. And my hand was probably covering it most of the time, but because there's not a significant enough load to draw any current, we didn't see any voltage or any current pass through our clamp. When we put a load on it, that's when we'll be able to see this, but I just wanted to give you a visual representation of what we're going to do. So we're going to go test a load, and we should see we will only have 1 meter, and I'll try to get another clamp meter so we can measure current on the high side, current on the low side, and then we'll be measuring voltage and see what kind of load we get and confirm that it's still working okay. I'm going to take the plate off. That will expose the lugs to the clockwise, counterclockwise, and neutral of the motor. On top of the housing right here, you probably barely see that, I have written down the coloring of the wires from top to bottom. So it happens to be blue, red, white, and I've got BRW marked on here. So I'm going to go ahead and take the wires off. Just with some needle nose pliers. And why did it do that? Now, obviously the capacitor was not discharged, so there was some voltage still on the cap. So let's go ahead and take a look at what we got here on the plate. All right, so here on the plate it's got labeled clockwise, counterclockwise, and then the line level. So we'll plug black and white into the top two lugs, and then we'll just take green and plug it into the bottom lug for our return, our neutral line. Okay, so we got clockwise, counterclockwise, and then our neutral. Okay, so I'm going to go ahead and energize the circuit, and we should see no voltage. All right, so we're showing 17 volts, but we probably know that that's capacitance voltage. So what we'll do is we'll switch the meter over to low impedance. And so we got no volts. So that's exactly what we expect to see. So I got the gate in a halfway open position. So whether I flip the switch up or down, I should be okay. And we should notice exactly what we're seeing right here is exactly what we want to see. So no voltage right now, and then no current, obviously, because there's no load. So we'll just put it in the up position and see what we get. So we get, let's see, what the heck? Can never just go right, can it? All right, so let's see what we get. So we were getting 3 amps on the high side, 3.2 on the low side, so we'll call that the same current draw. And we're getting 121 volts, which is only a percent or so down from what the actual standing voltage is. So that looks like everything tests okay, and I don't know if the high side or having the high side and the low side on this is beneficial. It looks like you get the same reading either way, but we'll just run it a couple more times and just see what we got.
Don't forget to like and subscribe.
Adapter on there. I'm going to do a review on that sometime soon, but it wasn't everything that I thought it was going to be, but it does exactly what it says it's supposed to, which is allow you to connect to this meter over your phone. But I was hoping that they would have it to where you could actually update the meter from here, since it has that mini USB connector.